What's poppin' YouTube? Code Adventurers. Welcome back to the Advent of Code 2023. Last night, we conquered Cube Conundrum, a dice game that had us on the edge of our coding seats, deciphering the number of dice in a bag based on the colors pulled out, red, green, and blue. If you missed it, be sure to catch up, because tonight, we're diving into day 3, and the coding festivities have just keep getting better. I'm Chris, your coding companion through this digital winter wonderland of algorithmic puzzles. If you're ready for more brain-twisting challenges, hit that like button, subscribe, and don't forget to ring that bell to stay in the loop on all the things of Advent of Code. Now, day 3 awaits us with a brand new challenge, promising to push our coding skills to the limit. The excitement is real, and I can't wait to see what awaits us behind this coding curtain tonight. Grab your coding snacks, clear your IDE, and let's unravel the challenge waiting for us on day 3 of Advent of Code 2023. Are you ready, Code Adventurers? Let's do this in 15 seconds. Day 3, gear ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number, and you should include it in your sum. Periods do not count as symbols. Here's an example of the engine schematic. In this schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. 114, top right, and 58, middle right. Every other number is adjacent to a symbol, and so is a part number. Their sum is 4361. Of course, the actual engine schematic is much larger. What is the sum of all the parts in the number engine schematic? Okay, we'll take this input. I need to reread the question. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand. Nope. But apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Okay, so 467, when we talk about adjacent at a diagonal, you've got these 3 dots, so nothing below, but it is 1 removed from below. So, but 114, 1 below, and then 1. Okay, so that's why it's not. So let's look at 35 is, because directly above it is a symbol. 633 is because there's a symbol here. 617 directly to the right. 58 is not because the box surrounding it is not. 592, not above, but directly to the right. 755, down 6. All right, so how do we solve? Really, this is just traversing a matrix or working the matrix. We essentially have a grid, and in the grid, we want to check certain values. So we can loop through the grid and go through it, and we want they're not part of the numbers because they're not adjacent to a symbol. So what we can do is we need the full number. So we could go through and loop and get the index of the first position of the number every time we find a number. Keep walking forward until we find another number, or the final number until we find a period. Once we find a period or we hit the length of that slice, that gives us basically our beginning and end. So in this case, it would be 0 and 1. And then from there, we check our values above, to the left, to the right, below, and then below +1 of our right of it, left one, so on and so forth. And that'll give us the bounding box, so to speak, on our values. We do need to check all three of these. So I think that is going to be our approach, is first find anything that is a number or anything that is not a period, bound it until we get to the next value that is not a period, which will give us the end, and then do all of the checking around it. So I laugh a little bit because I did talk about switching everything to strings, which I did, but this is essentially, if we do a split on the file, this is just, we can just use strings to get this data. We just have a slice of string. And so our first index would be what row we're in, and then our second index would be which column. So we'll loop through all of these. Yeah. So that's our test input, and we want the things that are not, and we know our value is 4361. So let's get that running. Okay. We know we're wrong here. And day 3. Okay. So we've got strings. We're splitting it. In this case, I do want to loop over it, but we're just gonna, it's not really a grid, but we'll call it lines. And then our score. So we're not gonna, I don't think we're gonna do like a get score function. I kind of feel like we could take a couple different approaches here. If I make it more generic, I could just find all of the numbers in the test data set, meaning that I could loop through this once and just say, okay, number here with the, X and Y of this, X, Y begin, X, Y end. Now we have all the numbers in the grid. Then we can check all the values. But I'm trying to anticipate, I think, too much. And let's just not anticipate. Let's go through. So if we go through each line, we're going to need this, because we'll call it our X. At least in this input, I don't see all dots. Well, there is this one which has no number, which is fine. So we need to go through each character in this So we're going to say if R is greater than 0, this should be less than 9. So let's do this. NS will be our start. NE will be our end. Both will be -1. If we're on a number, then if NS equal -1, then NS equals 2. Yeah, we just need the Y position here. Continue. Okay, so then NE equal to Y. So our number start will only get set here, and then we'll continue only on the first iteration, and then we're going to set the NE equal Y. Only if we are a number. Okay, so now if R equals period, then handle number check. We'll do that in a second. But NS equals -1, and e equals -1. So what we're doing is we're resetting the number start and the number end if we hit a period condition. We're going to check here if it fits our criteria. We'll check up, down, left, right, etc. And then we need one other check, which is if we exit this for loop and number start if ns not equal -1, then we know we have a start and we have an end. So we have to do a final handle number check, and that is the condition in which we reach the end of the line. So now we've got our range, our indexes for the row of a given column. So our X is our row and our Y is our column. And so now we've got to check everything above, to the left, to the right, and below to see if it is a symbol. So the symbol, I don't know if they've included all of them in here, but there are more symbols than that. So let's go and take a peek at our test input. But you know, a symbol can be anything. I mean, we could just create a list. All right, so let's just create a func for that. So func is has close. What's the term? What terminology do we use here? Has adjacent symbol. Has adjacent symbol. All right, we're just going to return true or false, and then we'll handle the calculations above. So what do we need for this? Well, we've got our input, which is a string. We've got our X, which is, and our Y, which is an int. Our Y start and our Y end. So that's important because we've got to check everything from the Y start to the Y end, up, down, left, right, down, +1, -1, etc. Okay, in the corners. So slice of string, that's our input. So now we're going to say if has adjacent symbol, and we're going to give it our lines, our X, our NS, and our NN. And we'll say if not that, then score plus equal vert dot a to I, and we'll give it string vert a to I lines sub X sub NS NE. I'm positive I messed that up, but we're gonna do a fum.print I. We'll just print that out, and then we're gonna plus I. Okay, we'll just say if nil. We'll just say panic. We'll just panic. It's fine. We'll know quick. Okay, that should pretty much handle that. And then also a little bit of a repeat. Maybe we'll just bring that out into a score function, and that way I don't have to repeat the code. But for right now, that should work. We're just doing that to make sure that we've got the right. I'm positive it's probably wrong, but let's check. So if X equals not equal to 0, we'll just say if X is greater than 0. So if we're on the 0x, we don't need to check everything above it. Otherwise we do. So if we're on X, then we just need to check We're going to create an assemble function, and that is just going to be a rune, and we'll figure that out in a second. Okay. Right. So we need to check for I equal to ys, I is less than or equal to ye. So we're going from the y start to the y finish, and then I plus plus. Okay. So that'll give us our for iterator on that. And then we're going to first just say if we don't need to check above, so only if x is greater than 0 do we check above. If it is, we are going to say if input x minus 1 I so that's going to check the above position. So what's wrong with this? Input is a string. Okay. I don't know what I was thinking there. All right, so it's going to return, it's going to input a byte, and then we're going to return true if it is a symbol. Okay, so that's going to take care of our above position. And we're going to do 1, 2, 3, 4. And so then we also need if x is less than length of input, then we're going to check +1. All right, so that's going to take care of our above position. So if we were to think about back to our test input, if we're here at 35, what I've essentially taken care of is I said, okay, everything from our start to our finish. The first part I coded was checking above. It's going to check these two values. The second part is going to be these two values. And so we need the left and right value. So we only really need to check the left one, right one, left up one, right up one, etc. So I guess I can maybe do some like indice math for that, but I'm just going to keep moving with my brute force here. So if ys greater than 0, then we're going to do input sub x sub y ys minus 1. So that's going to give us our left, and so we want left up. So we're going to say if x is greater than 0, that's our left up, and then our left down, which would be less than length of input. So less than length of input actually needs to be -1. We don't want to do it on the bottom one. So this length check here too, I think also needs to be, because if you think about it, I'll go back to our test input. If we're here, well, our length is 10, but we're at the 9th position. So I don't want to check something that doesn't exist. So we gotta make sure that if we're doing a length check here in these two positions. Okay, and so that's going to take care of our left side. And then we just need to do one more check, which is our ys is length of input sub x, again, -1. So our ys has to be less than our length -1. So meaning 1 to the left. So we're not going to check when we're here. Sorry, when we're at this rightmost character, we're not going to check the thing to the right because we can't. There's nothing to check, and we don't want to get index out of bounds. So with that said, we're going to do something similar here. So we want to check the right side. So instead, this is +1. This is +1. And this is +1. Okay. So if any of those are true, so what is a symbol? VS Code trying to help me and it's hurting me. All right, so if it contains, okay, that's fine. So let's go with a $sign here. Let's put all of our yeah. Well, in that case, VS Code is helping me quite well. All right, so let's see here. We'll start with our test input. So $, asterisk, pound, $, asterisk, pound. What else we got here? There's asterisk, pound, plus. I think plus. Okay. Plus. All right, cool. We're gonna start with this. We'll get rid of this. We'll just see if my test input passes. Out of bounds. Okay, index out of bounds. Oh, this should be a +1. I think it should be a +1 here. Yeah, so this is to the left. So these are always going to be ys -1s. And we're checking the left one, the above, and the below. And then similarly, we're checking the right one because it's the end. And we're checking above to the right and below to the right. Okay. All right, let's run it again. Same problem. So if x just make sure yeah, okay. So let's see what's happening here. Length of input. So that is, we're saying if x is less than length of input -1, we're going to check the next one. So if our length is 10, then that would be 9, right? Let's check. Did I add? No, there's no hard return at the end of the file. All right, well, here's what we're gonna do. We're going to print input sub x. Oh, 467.1114. Okay, so 467.1114. Yeah, all right, this is what I figure is gonna happen. We'll go with percent D, we'll say X, percent D, YS, percent D, YN, percent D, line, percent S, and then we'll go with X, YS, YN, 0 to 2, which is true. Oh, let me get rid of, yeah, an extra line here. Okay, what am I doing wrong? Why are we passing in -1? Okay, so that means that our problem is coming before this because we should not be passing that in. So if R equals, so it's on the second period being processed because this is assuming that because we reached a period that we've ended a number, but that's not necessarily true. So, and number start not equal to -1. So that we need to make sure that we're in a number because we shouldn't be passing into that function actual 16. Okay, so what are we actually scoring here? Actual 16. The input. Well, what's the 4361? So it's 114 and 58. Their sum. The numbers are not part of the number because they are not adjacent to a symbol. Every other number is adjacent to their sum is okay. Some of this wording. So they don't want the things that are the thing. Well, they want the things that are not. So I change this and run our test. 432. Remember what I said earlier? If you do recall, I suspect that this is wrong. It usually is every time I do it. So where is I being printed out? Yeah, so 6. Yeah, so we're definitely +1. And because I didn't make it a function, I got to do this in both places. Okay. There we go. All right, so that's done. So all we have to do now is, to finish this out, is just run the program. That's because I have not given it the test input. So symbols. That's a reminder. That's a terrible list. It's unfortunate that they did not tell us what those are. I'm going to cheat a little bit here, and I'm just going to check for anything that's not a period. I think that'll be fine. And so if we go back to our command here, if we go to our list of symbols, the problem is I haven't really, this isn't all the symbols. If you look at the text file, you've got some slashes, some ampersands, or at signs are at symbols. You've got some other things in here. Instead of me trying to define what that list is, what I'm going to do is just say, we don't care about numbers. So if b is greater than 0 and b is less than 9, right? Or if it's one of those, we're going to return false. So we'll say or b equals the period. So if it's a number or it's the period, it's not a symbol. Else return true. So that way we just eliminate this entirely. And if we run our test, so our test still test passes. So we can come back here, rerun, and okay, hold on. I think I might see what's going on here. It looks like our end is not set. So meaning that our number end is still -1, which is what's giving us the 0. So my question is why? I guess to start the, first off, that has to be true. It needs to include 0 and 9. Which is interesting that neither 0 or 9 was in the original input. I feel like AOC does this on purpose, where they leave out specific tests just to test your boundaries. Okay, so that was the first problem. The second issue is I realized just now that we could get into a scenario where there is a single digit number. And so anytime we set number start, we're also going to set number end, which should not change the results there. That should change this result, however. And here's our score. So let's pop this in over here. And that's not the right answer. Well, why? Did I do the same thing on the is symbol check? I did do the same thing on the is symbol check. Same bug twice. Probably should use an is number function if there is one. Okay. Is symbol, if it is a number or it's a period, return false, otherwise true. Let's look at our puzzle input for a second here. Okay. Did I have any other places where I did this problem here? 547. The number 8. So we've got 781. we've got 547, 547, 781. Where's 8? I don't see 8. I see 595. Okay. So okay. Number 4. %S. So we'll go with X, NS, NE plus 1. Literally that. And we'll repeat this in this other block. So we'll get more data. I don't need this anymore. I don't think. I do need that other part. Whoops. Yeah. So we skip 8. We have a bug. It's unfortunate. Let me just state the obvious. All right, so let's think through this. We come up to our periods and we come up to an 8. And we come here and the R is greater than or equal to 0 and it's less than or equal to 9. Can ignore that. So if the start is -1, it's kind of redundant, but okay. So if we reach a period and the number start is not equal to -1, which have been defined above. Interesting is that when we get to 781, let me just look at man, this one's eluding me. Okay. Okay, it's only going to print out those that don't have an adjacent symbol. So, okay, hold on. We're getting there. So, because I'm not seeing the line every time, we only print the line when we're doing a check. If X is greater than 0, check the previous. And if we're at the bottom, if X is less than, so if we're at, okay, let's look at our test. We definitely had is symbols above in our test input. So that seems like that is probably not the issue. You know what we can do? So we know from our text that there was definitely an attempt here. So what we can do is we know this much. The has adjacent symbol code is failing. Yeah. So we're going to put in sub x sub y start to y end plus 1. Okay, let's rerun this. Okay, so it's definitely failing here. We're going to go ahead and X is 130. We're going to create a conditional breakpoint. I just want to loop through here. And this is something really cool in VS Code. You can create a conditional breakpoint. So I can say X and Y start equal. So we want for the number 8. So the Y star is 32. So we're going to create that conditional breakpoint. And we're going to run this test. We're going to run it in debug mode. And what's going to happen is when we run it in debug mode, it runs the code until it hits the line where our YS is 32. So we're going to jump in. We're going to check X. X is 139. So I'm just going to run through these. If X is that, add this to our watch real quick. I mean, it returned false, right? Oh my gosh, I'm hunting a ghost. That is correct because 8 doesn't have a symbol around it. All the other numbers that did return. Okay, so that's not our problem. All right, what am I missing? So, it's like I miss the important details every time. So what is the sum of all of the part numbers in the engine schematic? It doesn't ask for it, even though the test had an example. It doesn't actually ask for that. It asks for what is. Okay. I mean, we messed up. I wasted some time. I clearly wasted some time here. I need to get better at that. Okay, so not a problem. I'm going to pull this out here to here. And we're going to run that there. And we're going to pull this out to here. And we're going to run this here. And if I rerun this, that's fun. Okay. So didn't see that one coming. Got lucky with that one because did I? How did I miss that one before? Definitely wasn't there. Definitely was at this one. We are anytime that we have -1. So the issue is here. We're assuming that just periods, but that's not true. If is symbol R, if the symbol is, if it's anything other than a number, then it will likely be a problem. Invalid syntax. If R equals a period or it's a symbol. Okay. Let's go. All right. So now let's see if this is the input. Oh, they're not part numbers. Okay. So I went down the right path initially. Take back what I said. You're looking for ghosts and you find them. So this is actually what we want. The problem is I was missing one particular set of input. Okay. Let's go. Man. What? I have to wait 4 minutes? I suppose that the reasoning behind this is so that people don't just try to send in a bunch of numbers, brute force it. I mean, that makes sense. Well, I struggled on this one a bit because of the assumption. The reason I struggled was because I assumed period would indicate the next, but it's period or symbol. And so what ended up happening was I ended up concatenating two numbers together. And then if we look at our input text, this here ended up getting brought in together. And then I might be doing something optimized in my check where I'm checking itself for any characters. I have to look at that, or I can look at that a little bit further. But what ended up happening is that threw off any number that was ending in a symbol was not getting captured correctly. Let me look at the text while I'm waiting patiently. What is the sum of all the part numbers? Not part number, because they are not adjacent to a symbol. Yeah, okay. So I understand, thinking through this a little bit more, and why this was the crux of the problem is that number. This would be another example. I don't know if this is the same one, but in this example, it didn't see any symbols around it, so it did not include it. But if you looked at each part, they both had an asterisk in the center, so they both are considered part numbers. So my result, this should be accurate now. Let's see if I have 9 seconds. All right, got it. Summarizing my mistake again, I just arbitrarily went with this. It turns out there were symbols directly after, and having a code, here we go again. Test input didn't really articulate that particular pattern super well. All right, let's do part 2. That took a really long time, but let's do part 2. Okay, part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump into the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help. So you pick it up, and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slow that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any asterisk symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. Evidently, my problem. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. In this schematic there are 2 gears. The first is in the top left. It has a part number 467 and 35, so its gear ratio is this. The second is in the lower right. Its gear ratio is this. The adjacent to 617 is not a gear because it is only adjacent to 1 part number. Adding up all the gear ratios produces this. Top left has part number 467 and 35. Okay, it wasn't exactly my problem, but okay. So, not too bad. So, very similar, but what we want to do instead is, instead of checking for every symbol, we check specifically for an asterisk. If the asterisk exists, we take that XY position and store it in a map, and we store the reference number. So in this case, 467, we go through, we find 35 with an asterisk, same thing. And then we come back through, and all of them that have more than one, we multiply. So let's implement. We'll go ahead and create a part 2. And same input, same process. So instead of is symbol, we're going to go with is asterisk. And this is simply going to be that. That still is symbol, so I take it back. Has adjacent asterisk. So we're not going to score in this case. We'll get to this in 1 second. So has adjacent asterisk. So is symbol is a func that takes in a byte. So what I'm going to do is actually create just a like if we do a func that takes in a byte, returns a bool. We'll call it check, and now has adjacent symbol becomes has adjacent. And this becomes has asterisk. What is asterisk? Yeah. So you know what? It's because of this. That just needs to be that. Sorry. Yep. Yep. Yeah. So in this case, we're gonna create a scorable, which is just a map of string to a slice of int, and every time we have an adjacent asterisk, instead of scoring, we're going to do scorable equal to scorable map of, we're going to do our X and Y is the key. I need the adjacent asterisk XY. That was going to be clever. Did some refactoring, and now it's forcing some more refactoring. So the problem is that our has adjacent just returns it true. It doesn't return the actual like XY coordinates. So what I actually need is bool XY. And so this is going to be X minus 1, I, X plus 1, I, X, YS minus 1, X minus 1, YS minus 1, X plus 1, YS minus 1, X, YE plus 1. So what I'm doing is not only returning the character, but the X and Y chord. And X plus 1, YE plus 1. Okay. So great. And because, oh, you know what, actually, I think we'll be fine. Yeah, so we're in what, part 2? So what we'll do is found fx, fy for the found x, found y. Found, now we're in here, fx and f and y equal to append. So, okay. So what we're doing is we're creating a map of the xy position of the asterisk itself. And anytime that's found, we are going to append to a slice of ints, and we're going to collaborate all that data. So where am I having a problem? Oh, that's int and int. Okay. Yeah. Okay. Got it. So as adjacent, we're in this case, because we're in part 1, I just got to make this compile. So we just need to check the bool. Also part 1. So this is my code from earlier because I decided to refactor it a certain way. And, well, yeah. So what we're doing is, this is part 2. Okay. And so same thing here. If we get into this state, we aren't scoring, but we're storing. So f of x and f of y. Okay. Yeah. Oh, that's important. I think it's a soft error though, because I think it still works. But okay. So now that we created this little map, we can don't really care about the key, do care about the values and range of scorable. if v length of v less than 2 continues, so anything only has 1, and then we can say score plus equal v sub 0 times v sub 1. All right, so that should and if let's go into our test. We're not doing this in our test anymore. This should still run as is, and func of what input, which is our string, and we get one in back. So this becomes part 1. What we're doing is just injecting our functions, and then this becomes f test.fn, and that will execute what function is being passed to it, and then test part 1 failed. The length if our length of v equal to 1, I should just say not equal to. Yeah, okay. So now we run this, and our expected 4361, but that's not true. Based on this is our value expected for part 2, okay. And that, not true. Okay. Why? Why is it not true? Has adjacent is asterisk. Is asterisk. Let's look at our test input. 35. Let's just let's print. Did I not save something? I don't think I saved something. Maybe I didn't save this last part. I don't know. Okay. Well. Too much, too much. All right, let's try it. All right, awesome. All right, well, finish that part up. So let's just do a quick review. Man, that was a tough one for me today. An hour and 49 minutes total is what I spent on this. Way longer than I should have. The second part went a lot faster, but let's just talk about this real quick. Based on our first part, the first problem was to look at this test input and only consider certain numbers, and certain numbers were only considered to be valid numbers if they were surrounded by an adjacent symbol. So adjacent meant anything that was above, below, so above, below, to the left, to the right, and then on the corners. So basically a square box around the number. And so I went through a few iterations of that, but effectively the way that I solved that was, let's go through each line, and for each line, we're going to keep track of these number start, number end, and SNNE. So that's the X, that is the Y coordinate of each string, or the index of each string that starts a number and ends a number. We're going to initialize those for -1. And then for each line, if our value is a number and we don't have a number start, we set both of them. Otherwise, we set the number end. I could probably get rid of this. And then finally, if our character is a period or a symbol, period is nothing, a symbol is something, and we have a number start, this indicates to us that we have now ended that current number. And so we need to check to see if it has adjacent symbols, and if found, we add it to the score. This is for part 1. And then we just tally all those up, and that gives us all of our potential serial numbers. Finally, if we loop through everything and we get to the very end, so this is when you get to the end of the string, or you've processed all the columns in a given row. If our number start is not -1, that means we're in a number. So go ahead and finish out our number based on the number end that we have, which is the current character that we're on, and catalog that and reset our values. So that's how we solved number 1. The main bug that I ran into here is that I had only this transitioning from a number and some other character. I wasn't doing this symbol check, so I was providing the wrong values. For part 2, a little bit simpler or faster approach, I did some refactoring so that I can inject a function, a check function, into has adjacent. So I went from checking everything to checking for asterisks. But the ask was that in this given set of input, instead of finding all the symbols, there were gears, and the way you would find those is if there were 2 numbers adjacent to an asterisk, but they had to be 2. So what I ended up doing was returning the XY coordinate as a map position and storing the numbers in that map. So you can see in part 2's implementation, similar to part 1's, honestly, I could probably reduce this further, but if found, we would grab the XY, the found X and found Y, that's the position of the asterisk, and we would add to a map, we would append the integers, and the key that we're using is the XY chord of the asterisk itself. This allows us at the very end to loop through our scoreable set, and if there's anything with more than 2 or less than 2, we can just eliminate. So if there's a number by itself, the instructions were clear on that. Otherwise, you add it to the score by multiplying the 2 numbers. That's what gives us our final value here. That's pretty much it for today. Please remember to like and subscribe and hit that like button. All right, I'm out.